Hi everyone and welcome to our webinar. Our topic for today is Modern API Gateway for DevOps and Cloud Teams. Today our agenda will be about discussing about the challenges of legacy API gateway solution and why do we need a modern API gateway solution for enterprise. Subsequently, we'll discuss about open source controllers that are available for modernizing your API gateway solution. And then we'll delve into IMESH API Gateway platform, which is released this month, and how it can help you to transform the network handling or the traffic management at the edge. Towards the end, our CTO of IMESH, Ravi Verma, will give you a demonstration of the product, and that's how we will close this webinar. Now, quickly starting about the current scenario, when we discuss with our clients and prospects, we understand that most of the enterprise today have adopted microservices architecture. Their applications are can spread across cloud, be it multiple clouds. Maybe some microservices will be in EKS, something will be in Azure cloud, etc. And these applications are divided into small microservices, which can be container based workloads hosted on Kubernetes. And they majorly kind of use CI/CD framework to deploy their changes faster, to get more revenue out of the business. Now, while all the technology stack has changed in the last 10 years, if you look at the way the network or the traffic is handled at the edge, is still kind of managed in a legacy format or a traditional way. So the edge has not evolved, and the software that are being used today are either traditional API gateways or the Ingress controllers that are used that are a bit of outdated or that are like 8-9 years old. So famous Ingress controllers that are used by most of the enterprises are either NGNX or Kong, or to some extent people use Istio Ingress. But the Ingress has its own shortcomings, and they have own disadvantages. We'll quickly look into it in the next slide. So there are 5 challenges. If we have to summarize the 5 challenges of legacy API gateways, then the first one is a developer portal. The Ingress controllers will not provide you a developer portal where developers can create and manage APIs independently. So there is no single interface where everybody, all the teams, different the folks from different teams and projects can come into one place and they can handle, and it provides a conducive environment to kind of create and manage APIs. The second important aspect of mainly Ingress controllers are supporting standard Kubernetes specification. Now we'll quickly look into the current specification as governed by CNCF, Cloud Native Cloud Foundation, that all the Ingress should support or conform to Gateway API specifications. Now, traditional API gateways like let's say MuleSoft, or maybe I can take other names, they do not support the new specification. Ingress controllers are somewhat catching up. That's the kind of story right now there. The third important point is advanced networking policies. Now, as a production system, you obviously want your production system to be resilient and reliable enough. And for that, you need to implement a lot of advanced networking policies like path-based routing, and then advanced networking logics, rate limiting, global rate limiting, to ensure that your production system is always reliable and resilient. And unfortunately, with this Ingress controller, it's extremely difficult to implement all these policies. The fourth important aspect is implementing RBAC. So imagine you have an enterprise and you have multiple teams at different located in different various geographies. Developers are present in different geography. Your DevOps is present in different geography. They're all working in different in a small projects. It is extremely important for the role delineation, like who can edit what resources. And if you are using classic Ingress controllers like Nginx, it is extremely hard to provide the least privileged access to developers to not be able to change any Ingress resources and objects. And finally, if you look at the developers' sentiment, they feel somewhat context switch to move out of their core business, where they're focused writing core business logic, to get into a different environment where they have to learn about YAML, about different configurations to be able to implement this Ingress specification for the handling network. It's a different ball game altogether. It may not be a cup of tea for all the developers, and they might get frustrated. So that resistance from the developers to implement network policies apart from the core work is also a bit of a challenge. So with keeping all this pointers in mind, it's high time that developers and the cloud engineers should realize that they need to modernize their API gateway. Now the question is, what is a modern API gateway? I mean, like what are the different qualities that are essential to ensure that API gateway for Kubernetes is modern? Well, so we have identified there are three important qualities. And number one is unified interface. There should be one single pane of glass where everybody, all the team members like DevOps, developers, your platform engineers, cloud engineers come to a place and they are able to kind of handle API, visualize, or kind of manage the API gateway or the APIs in general. The second important aspect is real-time dashboard. They should be able to understand what are the different gateways or the routes that are being created in the entire company, and what are their performance. Are they really doing good? Are they underutilized? Is there any high error rate that are occurring in a particular route? Is there some kind of optimizations that are required? And that's quite essential for the whole the company to understand or look at the APIs game. The third one is developer portal. I mean, there has to be a conducive environment which can provide developers to create and manage APIs for their applications. Some of the good companies that have achieved this for traditional workloads, when there was only applications, there was no Kubernetes, like MuleSoft, APG, etc. But with the Kubernetes coming in, people still use Ingress controller and they still expect developers to understand and learn Ingress gateway and then create Ingress resources, which is quite difficult. So developer portal will provide them the much needed UI to quickly and seamlessly create these APIs for their applications. They can create, deploy, and they can manage those APIs at will. The second important pillar, or the quality which qualifies API gateway for Kubernetes as a modern, is the core features of that API gateway or API gateway software. Number one, they should have all the built-in features for creation and management of both the gateways and APIs. They should provide the features like failover, retries, timeouts, global rate limiting, and local remitting, etc., which can help developers to improve resiliency and reliability of their applications or the service. Second, it should also provide the certain templates to be able to enable the security features or security policies like JOT, JWT authentication, OIDC, or basic auth, etc. The final one is about the GitOps style delivery. I mean, you cannot live or think about a delivery platform or a delivery process without having GitOps enabled in it. So there should be a mechanism where developers are creating the APIs seamlessly from the UI, and the backend there is an automated mechanism to ensure that everything is happening through GitOps way. All those UI is getting translated into YAML, and those YAMLs, when they get changed or they get approved or they get finalized in the source code management system like Git, automatically they get deployed into the desired environment. The final pillar is enterprise. Now, under the enterprise features, the number one is conformance with Kubernetes Gateway API specification, because that's a new standard by CNCF. The second important aspect, like I was describing, role-based access control, is extremely important for the role delineation delineation in an enterprise where developers should not be allowed to create and delete gateway, because that creates a lot of hassle. Gateways are nothing but the public IP address. So if they inadvertently kind of create a new gateway and they make the IP public, and any external folks get to understand the public IP, then there can be a lot of mishaps, and data can be stolen. So that can be a major incident and blow security incident for the company. So for that, the RBAC is extremely essential to practice least privileged access for your teams of on certain resources. The final point is scalability. Of course, your API gateway has to have that capability to scale on demand. Let's say if on peak season there's a lot of scale you're expecting, a lot of traffic you're expecting, your API gateway should be able to handle that load on that very day. Now, let us kind of look at the certain open source software controllers that are available today to modernize your API gateway for Kubernetes. Now, let me kind of quickly take you to Gateway API specification by Kubernetes. This is the site, gateway-api.sigs.kubernetes.io. So if you want to learn more about Kubernetes Gateway API, you can go through this website. And if you want to know more about Kubernetes API in general, then please look at our videos, YouTube videos. We have created dedicated videos and blogs on the Kubernetes Gateway API. Now, a few famous controllers that are available today, which can help you to modernize your ingress or your ability to handle traffic at the edge are provided by Amazon, Microsoft, Google, Solo, then Envoy Gateway, Istio, etc. But I will highlight a few important ones that are popular, and also they provide general availability of the software. So a few important ones are Envoy Gateway. So a lot of people, a lot of enterprises are adopting Envoy Gateway because that is quite light and quite fast. And we all kind of love Envoy Proxy. Envoy Gateway is built on the top of Envoy Proxy. Then there's Glue Gateway. Glue Gateway is an extended version of Istio Ingress. It is developed by Solo.io. And then there are Istio. Istio, as we know that Istio provides service mesh software, is the most popular one, and it always had that Istio Ingress gateway that could handle the traffic at the edge. Right now, they have improved themselves to conform with the gateway API. So if you install Istio, then your Istio-D will be able to kind of handle the network, the north-south traffic, or the network or the traffic at the edge with their Istio Ingress gateway. Another popular one is Kong. So these are some of the popular Ingress gateway controllers that provide support for gateway API specs. Now, quickly moving on. So even though kind of open source controller would provide a certain degree of capability that needs to modernize your application, one of the important element that is missing still is the unified interface. The first point, that is, with open source, you will not get that UI and a common interface where everybody can come into or log in into the system, and they can see the results, the dashboards, the real-time performance metrics of your gateway and routes. All these are not possible with the open source software. And with that, keeping that in mind, we launched IMESH API Gateway. Our gateway is first of all built on the top of Kubernetes-based Envoy Proxy, so it is extremely lightweight and scalable. It conforms to gateway API specs because it is built on the top of two controllers. Right now, we are supporting two controllers. The first one is Istio, and second one is Envoy Gateway. So based on whatever controllers that you would require, or it's a requirement to your company, we can provide that. It's a native integration. And our gateway is meant to handle traffic at scale for microservice-based application. Now, quickly providing a little bit information about the architecture. The way we have designed IMESH API Gateway is, the IMESH API Gateway will be able to manage the gateways. So open source gateway, like I was saying, the gateways currently we provide Istio and also Envoy Gateway. So based on your need, you can install either. And then the gateway creation can be obviously used by DevOps. So we provide RBAC from our platform, which will enable DevOps to just create gateways, and it will not allow developers to kind of create or edit or delete gateways. So that way, the role delineation is quite is there. Similarly, it provides the ability to create routes, and from with respect to creation of routes for the for particular backend applications or services, now developers will be given the rights to create routes independently. Now, with respect to network security, network policies like rate limiting, retries, timeout, circuit breakers, or security policies like JWT tokens, etc. So for that, any DevOps and developers can be given the rights to create network policies, and those policies can be attached to either gateways or routes. So this such kind of multi-tenancy or RBAC can be practiced inside an enterprise using IMESH API Gateway. Now, the different benefits of using IMESH API Gateway over using open source software or controllers for or the recent open source controllers are, first of all, since IMESH API Gateway is built on the top of those open source software that we were talking about, you get all the features, core features of, first of all, open source software like Envoy Gateway and Istio, whatever gateway that you use, you will definitely get those core features. On the top of that, you would get the unified interface, which will help you to quickly get started with respect to modernizing your API gateway for Kubernetes workload. So in short, our IMESH API gateway is fast, secure, and scalable. Number one, it enhances developers' productivity with API self-service. They will be able to kind of create APIs for their applications from the UI itself. It's pretty straightforward, seamless, etc. No learning curve is required on that part. The third aspect is RBAC. From the UI itself, the admin can quickly create roles for different resources for different team members. So implementing RBAC is extremely easy right now. IMESH API Gateway provides real-time dashboards where one can quickly see what are the different performance of gateways, and they can get insights if some gateway is not performing or their error rate is more than the threshold. They can get the idea, and they can take proactive actions to optimize them. And since we have built our product on the top of Istio and Envoy Gateway, we provide native integration with other CNCF products like Prometheus, Grafana, GitOps tools like Argo CD, and obviously we provide an extension, natural extension to Istio Service Mesh. So now in the next part of this webinar, Ravi, CTO of IMESH, will take you through IMESH API Gateway. He will be discussing about the installation and giving you a quick walk around about the IMESH API Gateway. Thank you.
Hello everyone. In this video, we'll be discussing about how to get started with IMESH API Gateway. So what are the things we'll be needing to install it? What are the prerequisite that we'll be seeing, and how to get started, how to use it, that we'll be seeing in this video. Okay, so the steps is few prerequisites are there that we need to follow, and after that we need to register to get started with IMESH API Gateway platform. So prerequisites are like we need to apply a few CRDs that we'll be discussing. Then we need to choose the controllers, which controllers to use. And after that, once those things are done, then we'll be registering our organization and we can start using IMESH platform. Okay. So this is the prerequisite. So we need one cluster, either EKS, GKE, EKS, or on-prem. Any Kubernetes cluster is fine. Then we'll be needing HEM3 and above. Then we'll be needing a gateway API CRD, which is gateway specification, which we need to have it to make it work, which is Kubernetes Gateway API specification, and it is standard. Controller, any one of the controller we can choose. Currently we support two controllers, Istio and Envoy Gateway. We'll be seeing both how to make it work. Once it is done, then we'll be installing an agent into the cluster, and it connects to the cluster and gets the required information so that we can start using the platform. Requirement is very minimal. It takes only 50 milli CPU and 128 MB of RAM agent, and that's enough. So without any further delay, let's get into the getting started video directly. So as I mentioned, we need to first deploy CRD, Gateway API specification CRD, and then we need to choose the controller. So first I'll be installing Gateway CRD. After that, I'll be using Istio as a controller, and later we'll be trying to install Envoy Gateway as a controller as well, and we'll be seeing both in action. Okay, so here is the release of Gateway API specification. This is the latest one. I'm going to install this. We support both experimental and standard, but for this video, as it's just getting started video, we'll be starting with the standard install. So just copy the link and we can run into the cluster. Currently, so I'm having one cluster which is clean. We can see it here. Still get NS. So it's a clean cluster. There's nothing here, and we'll be installing or configuring this cluster. What are the things will be needed to get started? Okay, so let's start. kubectl apply F. So this is the standard Gateway API CRD we are deploying. Let's wait for a couple of seconds. It will create CRDs. Yeah, so it's done. After that, we need to install any one of the controller. So either Istio or Envoy Gateway. First we'll try with Istio, then we'll try with Envoy Gateway. So for Istio, I'll be installing with istioctl command. So make sure you have this istioctl with you, or you can install with him as well. istioctl install set profiles equal to minimal. I'm keeping it minimal because I need only STOD, which is a controller, main controller. We don't need anything extra like Ingress and all. So only STOD is enough for this, as we are going to use as a API gateway. Okay. So I'm hitting enter. It will install Istio CRDs and STOD. In few seconds it will be done. So let's wait for that. STOD is installed. Fine. Now we are good. So the prerequisite, what we just saw here, I'm using a AKS cluster currently. Gateway PACRD we deployed, then we installed Istio controller. Now we will be seeing how to install this Helm. But before getting into the Helm, we need to register our organization, and there will be getting how to register the cluster. There will be getting command as well. Once we are done with installing the controller, now it's time to register to IMESH API Gateway platform and install the agent. So for that, what will be going is, so what we'll be doing, we need to open one link. So that we need to go to app.imesh.ai. Here we need to click on register, and here we need to give organization ID. So it will be like IMESH.ai, so IMESH-AI and name, email, AI test. So we can give any password here of your choice. Okay, and then we can register. Yeah, so once it is registered, we can log in. So we had given IMESH-AI that I'm choosing as an organization ID again, and then we need to sign in. For the first time when we are logging in, it will be asking to verify the email address. So that email address, whatever we have given, that need to be a valid email address. Okay, let's try that. Yeah, so we should be getting one verification email in the email address which has been given. So I would have been receiving that. Okay, now we got it. So we can copy the link. We can open in browser to verify it. Let me do it here itself. And we should be able to log in. So once it is verified, it will take to the dashboard. As no cluster and all is there, so we need to add a cluster. So we can click here, we can register cluster, and after that we can start deploying our gateway and routes. So first of all, we need to deploy an agent. For that, we need to register that cluster. Sit it here, give any name. I'm giving demo cluster. These are the commands we need to fire in sequence. And this last command is valid for only 5 minutes. So we need to run this command within the 5 minutes. Otherwise it will expire and we need to redo the registration. So as this iMessage sent is already, repo is already added, it's giving this message. We can go ahead and update the repo so that it pulls the latest repo image, and we need to fire this command to install an agent. This is a very minimal agent which interacts with the cluster, and it's kind of linking between the cluster, like your cluster, and IMESH API Gateway platform. Okay, so if it's already there, let's clean it out. Uninstall agent. And then mesh. Okay. Now let's try installing again. Yeah, it got installed. Now if we hit done and if it registered successfully, we should be able to see it here. Yeah. So demo cluster is registered, and now we should be able to interact with the cluster which we just registered. Okay. So now all those things, that command line things is done, all those things now will be going to the platform dashboard. We'll be able to use all subsequent things. For the demo, what we'll be doing, we'll be deploying a famous Istio book info application, and we'll be trying to access it from the outside. So let's go ahead and deploy a book info application. So for that, kubectl apply. I have downloaded this one, so it is available in Istio GitHub site. Anyone can download. It will be deployed into the default namespace. You can check that. kubectl get pods. Okay, so the application is deployed. But we would not be able to access it from the outside because there is no gateway, nothing. Currently, there's nothing. So we go ahead and create a gateway first. We need to select clusters. So the registered cluster here, select it. and then add gateway. We can give name of the gateway. So IMESH API gateway. Gateway namespace. We can select any one of the existing namespace or we can create a new one. So I prefer to create here new one for the gateway. Gateway namespace will be created. And as we installed our controller, Istio controller, so I'm selecting as Istio. We have support for both Istio and Envoy Gateway. You'll be seeing that Envoy Gateway in some time, but as we install the Istio controller, we'll be going ahead with Istio controller here. Other things I'm keeping for now is default. Let's continue. Here we need to add a listener. Listener is nothing but on which port we want to listen and which protocol we want to listen for. So that's the configuration. So we need to hit it here. Listener name, I can give it HTTP, sorry. Match host name, I am not giving for now. I'm keeping it default. It means it will be able to listen for anything, any request. Let's select the protocol HTTP and I'm giving the port as 80. Other things I'm keeping default. Namespace. Namespace here, allowed route means which all routes can be allowed to connect to this gateway. So whenever we have a route, so same means if so that route also should be there in the same namespace of the gateway. All means any namespace I'm keeping for all so that it will be easier for us to see. Then save and then we can hit deploy. So gateway deployed. You should be able to see here. Currently configured is saying cross. It will be up in some time because it creates the load balancer and all into the public cloud, and then it assigns the IP. We'll be seeing. So refresh it here, and once it is up, we should be able to see those IP here. Okay, so let's wait for that to get up. Get. Meanwhile, we can verify. kubectl get gateway class. Okay, already Istio gateway class is present that we are trying to use it. Get HTW. Okay, it is true. It is having address also. Yeah, so it got the address, but if we try to open this address currently, we'll not be able to use it because there is no route to listen currently. There is no route attached to that gateway. It has just load balancer is deployed. It is functioning. It had got the IP, but there is no application behind that one to listen to that. So for that, second step is we need to create a route and then link that to the gateway and the port whatever we. So whenever we get a request on this IP and the particular port, that request will be forwarded to a route which we are going to register, and that route will forward that request to the desired application so that it is desired microservice. So let's go ahead and create route. So here we need to hit route, add route. I'm giving HTTP or book info route. Route namespace, either we can create or we can use anyone. I'm keeping default. Currently my application is also in default, so I'm just deploying that to avoid any complications at this point of time. So just getting started video. All advanced things and all will be covering in next videos. Other things will be keeping default. Next, here's the gateway linking. So whatever gateway we created, so one route can be attached to like any gateways and all, any number of gateways. So whatever gateways so far we created, that will be listing here. So whenever we press the drop down, we'll be getting that. So this is the gateway we created, And this is one of the listener we created, port 80. So that also we can select. If we had created multiple listeners, so we'll be seeing that one here. So as we created only one, so it was showing only one. Then hit continue. Here we can give conditions, advanced conditions. Okay. Then we can give actions. Actions, lot many things are there. Modify request header, modify response header. All those things are there. Those are the advanced actions we can perform. Currently, I'm keeping it simple, doing nothing. Just go ahead, and whenever the request is coming, just forward that request to this service. So that service I'm going to select from a default namespace, in which we deployed our book info application. So namespace. Then we need to select which service we want to forward. So that's the product page service. We need to select port. It's pulling all the information. We are not mentioning anything manually and all here. So all these things information it pulled, and all the things I'm keeping default. Now we can go ahead and deploy the route. Route deployed. Here we can see the route, and it is attached to this gateway. So now when we hit this one, we should be able to get that page up and running. So let's go ahead, hit it out. Yeah, it's running. We didn't go anything, we didn't fire any command into the terminal and all. We just installed Istio as a controller, gateway controller. We deployed a gateway API CRD and just a small agent for the platform. And now all other things we should be able to do it from this platform. We need not to go to terminal. We need not to open anything after that. So all this configuration, it was very simple. Just few clicks and it's up and running. Okay, we can go ahead. We can verify this application. So it's running. It's a famous application. We can refresh to see if we are getting the response from all this versions. So the review is having 3 versions. Okay. So when we refresh, it will be changing here. One is without a star, one will be black star, and one will be with red star. So let's see. Refresh a couple of times. Yeah. So all 3 microservices up and running. We are able to get this one. So far what we saw, it was with Istio as a controller. Istio controller we used. Now it's time for the Envoy Gateway as a controller. The second thing we'll be doing. We can install the same into the same cluster, both the controllers. We can have it separately. All those options are there, or either. So, but I'll be installing that second controller also into the same just for the demo purpose. But usually one of the controller will be only there, and that will be sufficient. But for the demo purpose, I'll be installing the second one also into the same cluster, or better, I'll uninstall this one and install that the Envoy Gateway one. Anything I can do. So I'll try to install along with this only. Okay, so for that, what we need to do, we need to go and install our Envoy Gateway. So we can come here and we need to fire this one. It will be installing Gateway API CRD as well as Envoy Gateway controller as well. So if we are using Envoy Gateway, we need to install Gateway API separately. That's one of the advantage here. Okay. So let's go ahead and deploy it. Fine. So now we should be able to see. So let's verify if we have what all the gateway classes we have. So currently we have only Istio 1. So Envoy Gateway by default doesn't deploy the gateway class. So for that we need to create and deploy a gateway class. For that we can create a gateway class similar to this. Metadata name and controller will be Envoy Gateway controller. Okay, this is the thing we need to deploy. That's it. And after that we should be able to use it from our platform. kubectl apply Envoy Gateway. Okay, it's created. Now we should be able to see both are up. Okay, now if we try to deploy anything from the platform, we should be able to use it the Envoy Gateway controller as well. So let's go ahead, create another gateway. Let's name IMESH Envoy Gateway. Gateway name space again I can give anyone. So let's create another one and give a name IMESH EG. Save it, select the controller as Envoy Gateway and keeping other things as default. Continue similar to that previous things whatever we did. HTTP listener I'm giving port 80, similar configuration, save and deploy. It's deployed. So now again similar kind of thing. Here the another gateway is deployed now and it should be getting IP in some time and that IP we should be able to use it. Again it is creating the load balancer and all and assigning the IP now we got and it is configured, it's up and running for use. But again there is no route, so when we try to open it we'll get nothing for now. So again we need to attach that route to this gateway. So let's go ahead and create another route. So I'm just giving name easy route, keeping in the default only other things as the default. Gateway linking. So now as we have two gateways, we can select any one of the gateway. So we tried with this one, Istio one. Now we'll be trying with the Envoy Gateway ones. Listener again, same thing. Continue. HTTP rule, keeping other things default. Just service we need to add. Default product page, port again, and deploy. Done. Okay. So now both two routes are there, two gateways are there. Now if we try to hit that IP of Envoy Gateway, we should be able to open it as well. See, both are having two different IPs and both are working fine. So both controllers, both the gateways are working fine. Perfect. So that's all for this video. All the features, all the advanced features and all we'll be covering in future videos. This is the video of how to get started with IMESH API Gateway platform. If you have any question at any point of time, please feel free to contact us at contact@imesh.ai, and we have a Slack channel as well. Visit our website and join the Slack channel. Thank you.